class. This is Harshvardhan Shah, your physical chemistry faculty. We are discussing ionic equilibrium and today we will be continuing with salt hydrolysis. So first of all, we will try to get a physical understanding, physical meaning of what exactly is salt hydrolysis. For that, consider water, a beaker in which water is taken. pH of the solution, as we all know, is 7. But when we take water and dissolve common salt, NaCl, into it and determine its pH, we again get pH reading 7. That is, common salt when dissolved in water have no effect on water. That is, in other words, there is no change in pH of water. This is our day-to-day experience, and out of 100 cases, 95 times we get the same result with salts which we have day-to-day use. But when we broaden the concept or aspect of salts, we see that there are certain salts which show different pH effects on water. That is, sometimes we get pH 7, sometimes less than 7, and sometimes greater than 7. We will try to take different examples and understand this. Consider 3 different salts. Let's say KCl number 1, second NH4Cl, and thirdly CH3COON. Now we add these different salts into water and then try to determine the pH of water, or you can say the solution resulting. When KCl, potassium chloride, is added to water, we see that there is no change in pH of solution, that is, it remains 7. But when ammonium chloride is added to water, we get a change in pH. The solution slightly becomes acidic. For example, let's say that it becomes 6.2. In simple words, we write pH has now dropped below 7. It's less than 7. In case of sodium acetate, the pH of solution slightly increases than 7. For example, it becomes, let's say, 7.9. In this case, the pH is greater than 7. So, we have 3 different cases. The case in which a salt added to water had no effect on change its pH. Secondly, we added a salt in water and there was change in its pH. So we have these 2 cases. Case number 1, in which pH does not change, that is, it remains neutral. Secondly, pH drops below 7, that is, it becomes acidic. And thirdly, pH is greater than 7, that is, it becomes basic. Now, let's understand the concept of salt hydrolysis in this, that is, its chemistry. What exactly is salt hydrolysis? Salt hydrolysis is nothing but when we take water and add salt to it. If that resultant solution has different pH than 7, then we say that the salt hydrolysis has occurred. And if the pH remains unchanged at 7, we say no salt hydrolysis has taken place. That is, in case pH is 7 neutral, we say no salt hydrolysis has occurred. But when there is change in pH of solution, that is, these 2 cases refer to salt hydrolysis cases. Now, our first and foremost aim is to understand that which salts will produce no effect on the pH of water, that is, no salt hydrolysis will occur, and the salts which will produce salt hydrolysis, that is, it will have an effect on acidity or basicity of solution. For that, we will first take some examples. Few examples of salts which have no effect on acidity of water or basicity, that is, they do not undergo hydrolysis. For example, and so on. We have numerous examples in this case. These are those salts which do not show salt hydrolysis. Now let's take few examples of those salts which produce salt hydrolysis. And these are the examples of those salts which produces salt hydrolysis. Now we will try to understand which different salts are producing the effect of salt hydrolysis and which are not. For that we need to understand that which ions, that is cations and anions, are playing roles into this. For that we will understand the concept of strong acid and strong base. So what are strong acids and what are the anions present in it? Strong acid, for that you should remember this list: H2SO4, HClO4, HNO3, HCl, HBr, HI. This is a list of different acids which are categorized into strong acids. And what are the anions present in these strong acids? H2SO4 undergoes ionization to produce SO4 2- its anion. In this, ClO4- perchlorate, here nitrate, here chloride, here bromide, and here iodide. Similarly, we need to understand a list of strong bases and the cations present in it. For this, we will generally take example that in periodic table, the cations which are placed in group 1 and group 2, these cations, when form hydroxides, these bases will be strong bases. For example, lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. Like this you can write numerous. And here my intention is to just give you a list and not exact all details. So what are the different cations present in them? Li plus, Na plus, K plus, Rb plus, etc. So now make this a point that those cations and anions which are produced from strong acid and strong base, their salts will show no effect on the pH of water. That is, they will not undergo hydrolysis. So take an example, NaCl. NaCl is a salt formed from a cation which comes from a strong base and anion Cl- which comes from a strong acid. Hence it does not show any salt hydrolysis. But when we take example of this formic acids and KOH, we see that this particular salt is coming from formic acid, which is not a strong acid, and KOH, which is a strong base. But one of the part is not coming from strong, and hence we say that it undergoes salt hydrolysis.